Hello, COVID kids. I only have a few COVID kids now. Um, so where we left off yesterday? Okay, where we left off yesterday, we had added and we had multiplied and we'd raised them to a power. So we have a few other things that we're going to do with monomials. So let's start with the first one. We are going to, you knew this was coming, you knew it was showing up. We are dividing these bad boys. Dividing monomials. I'm going to be honest, there is the shortcut way, and then there's the Mrs. Tarantino longer way. I am not going to lie, when I do these, I often do them the longer way. But there is a really, really important key on these. So here we go. The first one we're going to look at looks like this. 8x to the third, y to the sixth over 12 x to the fifth, y to the second. Okay, so we know it's dividing. It's a fraction. That's what that divide line means. That fraction line means divide. But here's where your teachers have been lying to you for many, many years. They talk about the property, because they're all big liars. They talk about the property. Is this not true? They never talk about reducing the fraction in the front.
I always do.
Then you're the best. Everyone else. I feel like those eighth grade teachers, they come in and it's like, oh, you just subtract. It's like, you gotta do the numbers in the front. Such liars, all of you. That's right. So here's what. This is a two-part problem, right? So the way we treat the big numbers and the way we treat the little numbers are different. So let's talk about these goofy big numbers first. We got the 8 and we got the 12. So here's what I want you to write down. And if you get nothing out of today, if you realize this, you are in good shape. So the first step is going to be this. Reduce the big numbers, right? Reduce the big numbers. So what we have a tendency to do is that we're like, I get how to do the x's and y's, but what the holy hell do I do with the big numbers? This is like a fraction, so we have to reduce it first. So I'm going to ask all of you to look at your neighbors. I want the biggest number you can think of that goes into 8 and 12. Talk to each other. What's the biggest number that goes in?
53.
Not 53. 2 does work, but I want the biggest, and the biggest in this case is 4. So the first thing that we're going to do when we do these problems is we are going to reduce that guy by dividing by 4 each of them. So watch what I get. I get 2 on the top and 3 on the bottom. Man, after doing this for 30 years, this is where kids make a mistake, and you think that that wouldn't be it, but it is. Now, I'm going to show you the long way to do this, and then I'm going to talk about the shortcut if you like it. So here's what I want you to think about when you're dividing these babies. I want you to think about just canceling. So check this out. I've got 3 x's on the top, and I've got 6 y's on the bottom. I've got another 5 x's on the bottom. Those look so pretty. And I've got 2 y's on the bottom. So when we divide, in essence, what we're doing is canceling, and we're keeping where more of them live, right? So watch what happens. These guys, this guy goes with this guy goes with this guy goes with this guy. So I'm going to have x squared, and you know where he lives? He lives on the bottom because that's where more of them were. So it's going to be x squared on the bottom. And on the top, this guy goes with this guy goes with this guy. That's it. I'm going to have 1, 2, 3, 4 on the top. So our final answer on this guy is going to be 2y to the 4th over 3x squared. Now I'm going to show you shortcuts, right? But if you are ever getting confused, if these ever don't make sense to you, this is what you want to think about. And all I want all of you to realize is this. when you decide where to put your X's and Y's, where the majority of them live, either upstairs or downstairs, that's where your final answer is. Because, man, I have a lot of kids who will get this and put this X squared here. Well, let's see if I can actually do it. Sometimes the board will let me. Will it let me? Oh, no. Sometimes this little X squared, they'll have it up in the top. Okay? So here is the shortcut method. The shortcut method says this. You can just subtract, right? 5 take away 3, but you have to think to yourself, I get 2 X's left over. Does it go on the top or the bottom? And my answer is, it goes where the majority of them live. If the majority of them are on the bottom, your X's live on the bottom. And if the majority are on the top, your X's are on the top. So please write this down for our second little step. Let's go ahead and get that really nice. Our second step, I want my pen to be skinny. My second step, 1, reduce the big numbers. 2, subtract matching letter exponents. Answer, did I spell that right? Where the majority live. And you're going to think, MST, that doesn't totally make sense. So we're going to try one. Are you ready? And then, sorry, this is where you come in. Are you guys ready? Here comes one for you. Yeah. Okay.
What am I doing?
I'm going to give you an example. You're just going to do the example.
Wait, what did you say?
No, we talk. Okay. Okay. Am I good? Can I get rid of this? No? Okay. Now? I was joking. Okay, thank you. Okay, here we go. Try this one. Here you go, everybody. Rock and roll. There you go. Give this one a chance, please. There you go, rock and rollers. Hey, Matt, while you're there, kick Santiago underneath the desk. Santiago, you can do this on your whiteboard desk if you want. Just do this problem. Do it on your whiteboard desk. You don't even have to do it on paper, but just do it on the whiteboard desk. We're simplifying. Yeah, nice. You know, we're going to do log and exponents, but I just need to make sure that they remember the rules. So we're just because everyone's, yeah, and we're going to do this. Yeah, we're going to do this in a second. Okay, we ready? So here's what we got. 2 steps, right? So the first thing that we got to talk about is we got to talk about the big numbers. And we do it really kind of separate. It's its own thing. So a number that goes into 3 and into 9 is going to be 3. I'm going to divide by 3. I'm going to divide by 3. So here's what. 3 goes into 3 is not nothing. 3 goes into 3 1 time. And 3 goes into 9 3 times. Yay. Now I'm going to cross out my X's. I have more of them on the bottom. So it's going to live on the bottom, x to the 3rd. I have more y's on the bottom, so they're going to live on the bottom as well, and that's what I get. Here's what I have kids do year in and year out. They just put 3, x to the 3rd, y to the 7. You need that 1 on top, Matt, because it's holding up your whole number. It's like think of it like a tent without that hole in the middle, right? You need something to hold up your fraction. Questions? How many people got it right? Okay. Here we go. Rolling on. We're going to get a little tougher. Let me find what I want. No, I think I'm gonna go on. Okay. Next thing we're going to talk about. Our next little oh, not you yet. Not you. Never you. Our next property is easy, but my God, so many people miss this, and it drives me crazy. Write this down, please. Anything to the 0. Oops, let me spell that right. Anything to the 0 exponent is, here we go. Oh, this one kills me, because I swear to God, they've been telling you this literally since you were in 7th grade, and I'm amazed how many kids year in and year out below this. So take a look at this. I can take x to the 0. It's 1. I can take 50 to the 0. It's 1. I can take 300 x to the 3rd, y to the 5th over 2,000 x to the 10th to the 0 power 1. Here's why. We are not very careful as math teachers, myself included. We use the word cancel. We use the word cancel incorrectly. Watch this. If I have 5 on the top, let's go 5 plus 2 over 7. Is everybody cool with 5 plus 2 over 7? Yeah? What is 5 plus 2? 7. Do you agree that 7 divided by 7 is 0? No, it's not. It's 1. Things cancel not to 0, they cancel to be 1. The reason anything to the 0 power is 1, because it's not really going away. It's in essence canceling. It's saying x to the 4 over x to the 4. If I wrote this out, 1, 2, 3, 4, 1, 2, 3, 4, I cancel them. I want to say nothing, but it cancels just like that to be 1. It is why anything to the 0 is 1. So lambs and lambettes who are watching me, Joe's watching me on this one. Joe, so this is going to show up on a quiz just because I'm mean. I don't know how many kids will do a ton of work, and the whole time I'm thinking, it's to the 0. You don't have to do anything, right? Just watch for it. Anything to the 0 power. It's for my friends who are taking placement tests for college, and to my friends who are taking ACT, SAT. It's a trap. It is 1. Okay. Next one. Still not that. Here we go. The next one's a little weird. It's really one of the most important ones we do, and it's where your brains kind of explode a little bit. We're going to talk about our friend, the negative exponent. And again, I'm going to make you draw something really weird here. Write that down. Negative exponents. It's all about location. So here's what. I want you to think about these when we do these, that you're going to have little letters and little numbers, and they're going to have little negative exponents. And the whole point of a negative exponent is that that little letter or number is trying to tell you something. And what it's trying to tell you is, I don't like where I live. And if you move me, I will be happy. So I want you to take a look at this guy right here. I'm going to put x to the negative 2 over 1. Is everybody cool with that? All the negative 2 is doing is one thing. All the negative is doing one thing. He's saying, I don't like being upstairs. I would be happier if I could be living in the basement. And your job, hold on, is to make these little guys happy. And the minute, Santiago, don't talk over me, please. The minute you put them where it makes them happy, Cole, they become happy. So when I say to this little guy, well, where would you rather be? He says, downstairs. Once I move him, he turns positive. That is literally all a negative does. It doesn't make anything negative. It doesn't turn its neighbors negative. It just tells you I'm in the wrong place and I am unhappy about it. Watch this. If I have 5 to that 1 over 5 to the negative 1, I go to the little 5 and I say, you're unhappy. And he says, I am unhappy. And I say, what can I do to make you happy? And he says, I'd like to live upstairs. So what I do is I say, okay, dude, come upstairs. And guess what? He's happy and I'm done. If you know it, then you flip both, right? And the minute you put him in the right place, the negative goes away. But I need you, like, if you walk out with nothing else today, it's that negative exponents don't do anything else. They don't make this number negative. They don't make this negative. They don't do any of that. They just ask you nicely to change their location. And once you change their location, they are happy. You guys ready to try some? Okay, so here we go, rock and rollers. Let's do this. Okay, so here's what we're going to do on this bad boy. There are 2 parts to this problem. The first part is the big number. That's always the reducing, right? We do that first. And then the second part is putting people where they would rather be. And it's pretty easy. Once you put them where they'd rather be, they are happy. So give it a try. Do your reducing, and then ask everyone nicely, where would you rather be? And it's possible they're fine where they are. But if they're not, put them where they need to be.
Yeah, wait. So, like...
Ooh, watch this. I'll give you a little hint.
Some can stay, but doesn't it when you flip one guy, all of them flip?
No. So we treat the big numbers separate, right? Because I say to the 3, are you good? He says, I'm good. I say to the 12, are you good? Are you good? Now I'm going to reduce them. Everyone does. And then just move the people where they want to be. So let's do it. I'm going to do it with you.
Yeah. So, like, 4 goes into 5.
Ooh, so what number goes into 3 and into 12? 3.
Oh, yeah.
3 divided by 3? 12 divided by 3? 4. Did they have negative exponents? No, they don't move. They're totally good. They just stay there. Now I go to the X. Is he okay? Move him down. And then he's happy. I just moved the thing next that has a negative exponent. Great. Someone said that. How did you do?
What if the number is like?
Ooh, good question. Let's do that. Hey, Emma, this part is pretty tricky, so I need you to stay with me on this, okay? So here's what. You only move things, I'm going to say one more time, with negative exponents. So I'm going to show you something really weird. Are you guys ready? Watch this. Let's take a look at this guy. -3 over 5 to the -1. Oh. Okay. This is weird. If you guys can do this, this is impressive because this is weird. So let's do this first. The first thing I'm going to do just for the heck of it, remember we talked about this yesterday, everyone has an exponent. Even if you can't see it, it's right there. So I'm going to first say to the little -3, are you happy with where you are located? Here's the thing. Look at his exponent. Is his exponent negative?
No.
So he's good. Is he a negative number? Sure, but that's okay. He's just a weirdo, and he's kind of got a, he's kind of a,
bad mood.
yeah, he's got a bad mood, but he doesn't want to leave. It's like he'll be in a bad mood wherever he is. He stays. Now watch with this guy. I go to the 5. He is unhappy with where he is. He's going to come up to the top. So let me ask you this. Take a look at that guy. How can I write that nicer? Say it. Negative 15. Yeah. Only the negative exponent moves you. And numbers all have exponents. It's just ones. If I need to move it, I need to throw that negative 1 on there. Okay, so here we go. We're going to step up our game a little bit, Lammies. Let's do this. Okay, so Cole's doing this one and Sawyer's doing this one. These are my friends who don't want to take notes, and that's okay. Oh my God, you weirdo! You have no friends. Just had to throw that in. Okay, you got choices on this one.
A lot of choices.
So a lot of kids are totally fine subtracting with negative numbers. I don't like subtracting with negative numbers. So I'm going to tell you what I do. The first thing I'm going to do, obviously, I'm going to deal with the big numbers first. Then here's what I do. I put everyone where they're happiest, and then I do any canceling or adding. Does that make sense? So for me, I want to go ahead and move this guy down here and this guy up there before I start doing anything else. That's going to make my life easier. But some kids are going to get the fact that 3 minus 5 is the same as 3 plus 5. But that's not how I do it. I like moving the negatives. So here's what I'm going to say. Yeah.
I was just gonna say, like, if you move them to the bottom, can you combine them?
Yes, exactly what Aiden says. So here's what we're going to do. Let's start here for everybody. Can we all start with the big numbers? I need a number that will go into both 8 or 16 and into 24. I just said it. Yeah, I said 8. 8 and 8. Okay, so here's what I got. I got 2 and I got 3. Now, here's what I'm going to say. This is how I do it. It takes me an extra step, but I don't mess up. I say, little X, are you okay? And he talks to me because I have no friends. He says, yes, I'm good. And I say, little Y, are you okay? And he says, no, move me to the bottom. Little W, are you okay? He says, yes. Then I go to the X's down here. And I say, little X, are you okay? And he says, no, put me up at the top. Little Y, are you okay? He's good. And little W, are you okay? And he's good. Okay. Now, I'm going to clean this bad boy up. So let's look at all of our X's in the whole problem. I've got X's. Let's find them all. I have, blue. I have one right here, and I have one right here. When they're both on the top, what do I do with all those? I combine them. You got it. So look what I have. I've got 2 on the top. It looks like I have X to the 8. And then I cancel them out because I get confused. Okay, let's do all of our Y's. I've got 2 down there and another one. So it looks like I have Y to the 3rd. And I got 3. Now the last part is a little weird. I have 5 W's on the top and 1 W on the bottom. So how many W's do I have total, and where are they living, on the top or on the bottom? Anyone can tell me? I have on the top how many? Ooh, 4. 4, 4, 4. How is that? Okay. Okay, yeah. Because I had 5 up here and 1 down there. So it's like they can't, one of them cancels one of the ones on the top. Yeah? Because I just think of it as canceling more than subtracting. Okay, next thing is weird. There is a weird rule on the negative exponents. So think about this. You got a house. You got an upstairs and the downstairs, right? You might talk to your brother and he's like, I wish my bedroom was downstairs. And you might talk to your sister and she might say, I wish my bedroom was upstairs. Or your mother can come home and say, my house is driving me crazy. I want to change everything. And here's my advice. If you want your mom to be happy, make the change. So let me tell you what I'm talking about here. Write this baby down. I want you to think of the guy that's outside the parentheses as the mom. And what she's saying is everyone is in the wrong place. Everyone. So before we do this problem, the first thing, and this is a good life lesson, always make your mother happy, right? So what's going to make her happy, when it's on the outside, when you have a negative on the outside of a parenthesis, what it's telling you to do is flip everyone's position. So watch what will happen. I will take the 2x squared and put it on the bottom. I will take the 3y to the third and put it on the top. And now my mom is happy. Yes, yes, perfect. To get rid of that negative, right? But now I still need to finish my problem from yesterday. Now I'm going to distribute this to everyone, but don't forget, he gets it too. This guy gets it, this guy gets it, this guy gets it. Are we cool with that? So what's going to happen now is the 2 and the 3, here I'm going to show you, he's going to go to this guy, he's going to go to this guy, and he's going to go to this guy. Ooh, it looks like a little octopus. So I'm going to get y to the 6, 4, x to the 4. Is that scary? Is that weird? Can you do that? Yeah? Okay, you guys ready to try one on your own? I'm going to find a scary one for you. I'm taking it off the homework from last night for those kids. Oh, that was so mean. Oh, I think you can do this. Oh, I think you can. Oh, I like this one. Oh, okay. If you guys can do this, you guys are crazy good. Hold on. In a second. Okay. There you go. This is as bad as this gets. I'm going to give you a quick little hint here, just so you know. You can put some ones there if you want. You don't need that. Yeah, you see it is there. So 1, there you go. So if I was doing this problem, which I will in a minute, the first thing I would do is flip it and get rid of the stupid negative. That's what I would do. Some people want to distribute, and you can do that, but I think distributing that negative is a pain. For some of my friends, you can also flip it and then write it twice, and it totally works that way too. If this is overwhelming to you, just flip it upside down, write it twice, and start canceling stuff. It totally works that way too.
So, would you just put just the 2, like 2 the only thing that goes down? Nothing.
I would flip everything up here to the bottom, everything up here to the top, and get rid of that negative.
Right.
And then you start doing everything else. This is a lot. This is a lot. So if you've been thinking this whole time like, oh, Mrs. T is just doing stuff that we've already done. Okay, welcome to Algebra 2. This is the Algebra 2 piece.
Is the reason, are you flipping it, both things because of that?
Nope, because he's just think of him as someone with a bad attitude, right? Here's a hint, that -2 never changes, he's always going to be negative. He just has a bad attitude. It doesn't. Well, you might change later.
What'd you get?
I have no clue. What do you do? What's that?
I'll do it. Okay, you guys ready? We'll do it together? Okay, here we go. First thing I'm going to do, I am going to make a pen that's smaller because it's too thick. First thing I do, I flipped it. So I said 3a squared b3 c7 over -2 a3 b2 c0, and then I did that. Did I lose anybody? Everybody with me? Okay. Next thing I'm going to do is I am going to send that little 2 out to everybody. Everyone's going to get it, even this guy right here and even this guy right here. So here I go. I'm going to say 3 squared a4 b6 c14. Are we okay?
Why do you only add the exponents?
When we raise a power to a power, we multiply the exponents. That was from yesterday.
Oh yeah.
So do we not multiply by 3?
We will. I'm just not there yet. Like it will be 9 at some point.
Oh, yeah. Okay.
Does that help?
Yeah, thank you.
Okay, so here we go on the bottom. Did I lose anybody? Yes. You would. It would. I just haven't gotten to that yet. So what Hannah reminded me, and I just hadn't done it yet, is that c to the 0 is just 1. So you know what? I am allowed to let him go because 1 times anything is just itself. So he's good. Now, I have a few things to do. The first thing I'm going to do is this. What is 3 times 3? I'm going to have a 9 there. And -2 times -2. It should be 4. Okay. Sorry, that's messy. Okay. Now, here we go. Let's decide. I've got 4 A's up here. I've got 6 down there. Do more live on the top or do more live on the bottom? On the bottom. How many more live on the bottom? 2 extras. So here's what I'm going to do. I'm going to get rid of these guys and say, okay, well, I've got 2 left here. Now I've got 6 B's living on the top and 4 B's living on the bottom. So are there more on the top or on the bottom? So when I cancel them all out, there's going to be 2 left over, and they're going to be up at the top. And finally, the C's have no one else to cancel with. That's hard. If you were thinking, Mrs. Tarantino, you've been giving us baby stuff. Told you I would step it up a little bit. Talk to me.
With the C to the 0, can't you rewrite that as 1 and then when she gets to 3? Okay,
so it would just be 1 times all this stuff. So
you don't distribute the 2?
no.
So
Yes.
The one just doesn't mean anything.
It doesn't really cancel, it just doesn't show up. It's what is 1 times 4?
Yeah.
Yeah. So I don't want you to think it goes away.
Yeah.
Sometimes we like it there, but sometimes we're cool with it just not really showing up. Okay, I have 2 last things to tell you. Yes, question. Huh? The last thing I want to tell you is this. So I have 2 last hints to give you, and then I'm shutting up for the day. Hint number 1, and we'll say it again. -3 and 3 to the -1, totally different things, right? So this guy just is this, and this guy is just random, right? It doesn't make it negative, it doesn't come to the front, it's just about location. That's like number 1 thing I want to make sure you know. The second thing I want to remind you is this, and we've talked about this before. When you have this guy, we would love to be able to distribute it. We've talked about this. When you have a plus sign, you can't distribute, you have to claw. So I'm going to keep reminding you, especially for my friends going to pre-calc, that distributing thing does not work if there's a plus sign. Okay, so here's what you're going to do tonight. We're going to practice this stuff. You have answers on your table group. You can take a picture of it. You only need to do the odds or the evens. It's up to you. But I would say the bottom ones, you kind of run out of space. So maybe do this. Like if you're doing number 21, maybe fold your paper over. Do you know what I'm saying? So you have room to write it. Is that cool? So just odds or evens, and it's just good practice, and your answers are there. And we're going to play baseball. And I will check it. You guys are great. Great job there. Good notes. Oh, sorry for people.